All right, so essentially what we're doing is we're going to take the mass number of each of these isotopes, and then that's going to give us kind of our atomic mass, like what's the weighted average of all those isotopes, okay? So here's how it works. Now, here's the first thing I want to point out. Notice that my mass number is 20, which means it's neon, so I had 10 protons and 10 neutrons. But do you remember how one proton isn't exactly one atomic mass unit? It's really close, but it's not quite. And so that's why we have these longer numbers, because they're not exactly. We're close, but we're not quite there. Okay, so there's some discrepancy there. Okay, so here's how it works. We have our abundance, okay, but these are percentages. So to figure out that value, you would divide by 100, and so this would be 0.9048, and this one would be 0.0027, and then we'd have 0.0925. Okay, and so we're going to take that and we're going to multiply it by the mass, and then we'll add all of them up. Okay, so we're going to take the mass of 19.99244 AMU, and we're going to multiply that by 0.9048. Okay, so I'm going to run that. So I have 19.99244, and I'm going to multiply that by 0.9048, and that gives me 18.09. Okay, we're going to round there. Atomic mass units. And now we're going to take this 20, this one right here, 20.99384 atomic mass units. We're going to multiply that by our 0.0027. Okay. So 20.99384, and I'm going to multiply that by 0.0027, and so that's 0.057 atomic mass units. And then my last one here, 21.99139, I'm going to multiply that by 0.0925. Okay, so $21.9913 multiplied by 0.0925, and that gives me 2.03 AMU. And now the last thing I'm going to do is I'm going to add these three values together, and that will give me my overall weighted average. Okay, so I'm going to add those values together. So I'm going to take my 18.09, and I'm going to add that to my 0.057 plus my 2.03. So my whole weighted average of all those isotopes based on their abundance is 20.18 atomic mass units. Okay, so that's my final value there. Okay, let's try this one more time together, and then I'm going to have you do one on your own. Okay, so we have element X, and we want to calculate the atomic mass, or that weighted average. Okay, so remember these are percentages. So if we were to divide by 100, we'd have 0.0759, and then we'd have 0.9241. Okay, and what we're going to do is we're going to take the mass 6.015, and I'm going to multiply that to my percentage here, 0.0759. I'm going to add that to my next mass, which is 7.016, plus, or multiplied by its percentage, 0.9241. Okay, so let me run those numbers. I'm going to start with my 6.015, and I'm multiplying that by 0.0759. Okay, so that is 0.457 atomic mass units. And we're going to add that to this value. So I'm going to take 7.016, and I'm going to multiply that by 0.924. That gives me 6.48 atomic mass units. And so then when I add those together, I get my final answer of 6.94 atomic mass units. Okay, so that's the atomic mass. And do you remember how when we said to find the most abundant isotope, you look at the atomic mass and you round it to the whole number? So if I looked at my atomic mass, I'd round that to 7, and this isotope with this mass number of 7 is my most abundant. So give the next one a go on your own. You have your abundance and you have your mass. Okay, so don't forget to convert those. So you're going to have 0.198 multiplied by 10.013 AMU. And you're going to add that to 0.802 times by 11.009 AMU. Okay, and then you'll get your final answer there.